Section 7.1, exploring the characteristics of exponential functions. So exponential means that it's in this form, y equals a times b to the power of x. Couple of things here. A cannot be 0, otherwise we just have 0 times something, or y equals 0. Not that exciting. And b is always greater than 1, greater than 0 rather. Okay, so we could have fractions or any number bigger than 1. Okay, and b cannot but is not 1. Because otherwise, if you have 1 to the power of 50,000, it's just 1. This would just be a constant function. So we're talking about functions that grow or decrease exponentially, because that variable that we're changing is x, because we'll be given values of a and b. Okay? So here's a couple things that Francine and Kent did. So Francine looked at f of x equals 10 to the x. She put in different values. She graphed it, and she saw that it looked something like this. 2 times 5 to the power of x is not quite exactly the same, because 5 is raised to the power, and then the whole thing's times by 2. So that one, when x equals 3, only goes to 250. I know our scale looks similar, but sorry, the graphs look similar, but if we look at the values on the scale, they're different. Okay, and then Kent looked at these ones where our values of b are fractions. They're still greater than 0 and they're still not equal to 1, which were our instructions, so they're still okay. Okay, so this one we could see that 1/2 to the power of -3, so that's basically saying 1 to the power of 3, 2 to the power of 3, but the negative switches it, so 2 to the power of 3 is 8. Okay, and even if you're not sure about that stuff, just putting in your calculator. So see that those two functions look a certain way. Okay, so now what we're going to do is we're going to write down the characteristics of these things and see if we can see any trends. So the first one we looked at is y equals 10 to the x. So let's look at the x-intercepts. It looks like it has exactly 0. Like it's really, really close to. I don't think there's any way that we can get an x-intercept of 0. So none. The y-intercept. The y-intercept, ooh, there it is. Is it 1? The end behavior, okay, so this guy starts in quadrant 2 and goes to quadrant 1. The domain, so the x values, could it be any x value? I do think so. So all x, such that x is a member of the reals. And now, can it take any y value? It looks like it can't take anything less than 0. Y such that y needs to be greater than 0. Y is a member of the reals. Okay, let's look at the next graph, this one here. So it looks like the end behavior is going to be the same. It looks like here, like our intercept is going to be at 2, and I got that from here. So let's add these things that I just said on. So the domain and range are going to be the same. Any x value. The y's always have to be greater than 0. The y-intercept was 2. There was no x-intercept. And let's look at the end behavior. That one started and ended the same as well. 2 to 1. Okay, our next one, I believe, was 1/2 to the power of x, and then we had 1/4. 1/2 to the power of x, and then 8 times 1/4 to the power of x. That was right, okay? Oops. Okay. So again, no x-intercept. It looks like we have y-intercepts. In this case, it's 8, and in that case, it's 1. Wait a second. Is it 1? 1/2 to the 0. 1. 8. Okay. These both go from 2 to 1. They don't have anything here. No x-intercepts. The domains are all the same. So I'm just going to do this. And the ranges are all the same. So you can see that there's some characteristics that we see. Okay, first of all, no x-intercepts. Our y-intercept looks like the value of a, because really, if we have y equals 1 times 10 to the x. That's our a value. Here, a value. Our a value there is 1. So it really looks like our y-intercept is our a value. Our end behavior, it looks like it always goes from 2 to 1. And our domains and ranges, domains is any x's. The range is always y is greater than 0. Okay? What are similar to polynomial and what is different? Okay, let's look at this. These have characteristics in common. Y-intercept only 1. Domain is the same. But they differ because the x-intercepts in polynomial last chapter, we could have 0, 1, 2, or 3, but all exponential functions have no x-intercept. The end behavior, so polynomials could go from quadrant 3 to 1, quadrant 2 to 4, 2 to 1, 3 to 4. Exponential always go from 2 to 1. The range, only quadratics had a restricted range, but all functions have that restricted range. All of them must be greater than 0, all the ranges. Okay? A couple more things. Ken claims that all exponential functions in this form do not have x-intercepts. Do you agree? I agree. There's no way that it can cross the x-intercept. There's no way that we can get a value of 0. Francine claimed that the exponential function of this form have a restricted range. Yes, we saw that they all have to be greater than 0. Can you use the end behavior of exponential functions of this form to help you to decide if the function is increasing or decreasing? Explain. There seems to be two kinds. Those that increase from left to right, so that's when it looks like this. Increase from left to right, or decrease from left to right. So the general shape is about the same, so is the general shape of decreasing functions. So there's no way of saying where it begins and ends is going to tell if it's increasing or decreasing, but looking at it you can tell if it is. Describe any patterns you noticed in those tables of values. Notice that each table of values, as the x value is increased by 1, the y value is increased or decreased by the same factor. For example, in the table for f of x equals 10 to the x, that was right here, each time we increase the x by 1, the y value increases by a factor of 10. Okay? In the table for h of x, each time the value increased, the value of y decreased by a factor of 1/2. So it looks like depending on your b, if it's a whole number or a fraction, also depends if it's increasing or decreasing. So it looks like when we have fractions, we have decreasing. Fractions, this is 1/2 to the x, 1/4, decreasing. Whole numbers, increasing. Okay, so in these later on we'll learn our exponential growth and exponential decay. And those are things that we may have heard a little bit about in biology. Decay you might have heard about in chemistry, radioactivity, or physics. Okay, key ideas. An exponential function has this form. A cannot be 0, b has to be greater than 0 but not 1. They all have this form, 0 x-intercepts. The y-intercept is the a value. The curve extends from quadrant 2 to quadrant 1. Any x value, y is greater than 0. There are two shapes, increasing and decreasing, and we kind of thought that that increasing means that a is 0, b is a whole number, and here we think b is a fraction.